Hello everyone, good morning or good afternoon depending from where you are watching Azure Conf today. Welcome to this session on reducing latency on the web with Windows Azure CDN. The talk is going to be about Windows Azure CDN, which is the content delivery network. And what I will be showing you is how you can use it to speed up your applications, the reasons why you may want to use a CDN, as well as how you can use the Windows Azure CDN, of course. So let's dive in there. Let's first introduce myself. I'm Maarten Baljouw. I live in Antwerp, Belgium, which is quite a long flight from here. I'm a technical evangelist for JetBrains during the day hours, and in the night hours I also work on MyGet, which is a software as a service where you can host your own NuGet feeds and create your own packages and stuff like that. I'm also one of the driving forces behind the Azure user group in Belgium, and my big passion is Windows Azure, although also everything related to web. If you want more information about all these things, if you're interested in all my ramblings I do about all these technologies, do follow me on Twitter or check out my blog and have fun there. So the agenda for today, let's first start with why we may want to use a CDN. What are the reasons for switching to a CDN? Why? Then we will switch to the Windows Azure CDN and have a look at how we can work with the CDN on Windows Azure and make use of blob containers as the origin and as well as use cloud services as the origin for the CDN. After that, I'm going to show you a few things that you can also do with the CDN, which is serving up dynamic content. CDN is mostly perceived as a way of serving static files to people all around the globe, but you can actually also serve semi-dynamic content over the CDN as well. So that's the quick introduction to what we're going to see. So why would you want to use a CDN? Well, there's a couple of reasons for that. And one of the reasons there is how browsers work typically. So if you request a page on the internet somewhere, what it will do is download a bunch of HTML markup, and that HTML markup contains references to all sorts of resources, namely CSS, can be images, can be JavaScript, hosted on the same website or the same web server, can be hosted on a different server as well. So for example, if you have a user voice tracking widget on your website, or you have Google Analytics on the website, you will be downloading those JavaScripts as well. Now on top of that, those JavaScripts or those CSS files may also contain references to other images or other CSS files and other JavaScript files. So just fetching that one HTML resource may actually bring down a lot of other resources that you don't really know up front, and that can be quite a lot of resources. On top of that, your browser only has a finite number of concurrent connections it can handle per host. It also has a finite number of connections it can handle in total. So if you have a lot of resources that are being downloaded during a request, you will be seeing that the browser may actually queue them up and sort of keep the queue and then download all the resources and then fetch them from those hosts in series. So first process the first few ones, then process the next few ones. There's a couple of solutions we can do to that. First of all, we can bundle and minify our JavaScript and CSS code. So for example, if you have 5 CSS files, bundle them into one CSS file. So you only have to download one CSS file instead of those 5. Same thing with images. If you have lots of tiny images, what you can do is create sprites of them, create one image that contains all these tiny images, and then use some CSS to position the image at the correct location. So that's one way of reducing the number of concurrent requests happening to one or more hosts out there. Another way of solving this is using multiple hosts, and that's actually something a lot of websites do. Now, if you look at how browsers work, and if you look at all the different numbers of connections that the different browsers can do, you see there's quite some interesting numbers in there. So for example, Chrome only allows you to open 6 concurrent connections per host with a maximum number of 10 connections in the entire browser. So this means if you are downloading 10 resources, which is not too much, it's something you see on a lot of websites. If you visit them, you download at least 10 resources or a couple more, you're actually being queued by the browser by default, by definition, because the browser only supports 6 concurrent connections per host there. There's a lot of differences in browsers, but in general, it's probably safe to assume the smallest number there, because if you really want to serve up 20 resources on your website, you know you will be queued, and you know that some requests will have to wait for to be finished before the other requests will be done by the browser. Now, why should you care? I'm using bundling, I'm using minification, and I'm using a different host to host my website and my resources that I have on the website. If you look at the Microsoft website I have here, and you open the developer tools and you look at the network traffic happening, there's actually quite a number of things you can see. First of all is that resources are coming from a variety of different hosts. Some are coming from Microsoft.com, some are coming from the CDN, on which jQuery is hosted, for example. Others are coming from an image server, where you can see a lot of images are being downloaded. But as you can see in the timeline on the right, actually these requests are being queued. You can see the first batch of requests happens, then there's a small pause because we have to wait for them to download, and then the second batch of resources is being downloaded. So to speed up loading this page and make sure that the page can be served more quickly, it's probably easier to split the resources that are being downloaded over a couple more hosts there. Another issue with the internet and how browsers work is speed of light. You may know the speed of light is quite fast, and it would be awesome for travel if we could achieve speed of light. But unfortunately for us, only the internet works at speed of light, sort of. Because if you take the US and you take US East to US West, that's about 7,400 kilometers or 4,000 miles. You will see at speed of light, to travel that distance, we would need 25 milliseconds, more or less. But that's in a vacuum, because speed of light can only be achieved in a vacuum. Which means if we are using fiber optics, which are typically made out of glass or plastic, you have the refraction index of the materials there, and speed of light will be slower than you would expect. So in this case, imagine we had one cable spanning the entire US, and we had that cable in fiber optics. It would take us about 37 milliseconds to move from one side to the other side of the US. Now, there's an interesting thing there, because there's no cable spanning east to west. Well, there may be some cables doing that, but typically your internet traffic will not use that cable or do that. Typically it will go through some switches, through some routers, to maybe whatever is in between, even a satellite uplink, who knows. And that will further make slow down the connection you have between both ends. Can still be under 100 milliseconds, but you see the time taken to travel east to west will go up in that case. Now, TCP is a wonderful protocol on which the internet runs, TCP/IP. But in order for you to do a TCP request on the internet, you actually do quite a number of things. You request the data comes back, and then you send an acknowledgement. So for every packet you receive from a server on the other side of the US, for example, you will be sending 2 packets instead of just 1. On top of that, every packet will not be containing the entire image or the entire portion of JavaScript that you are downloading. The packets will be, it will be split up. The image and the JavaScript file and the CSS file and so on will be chunked, and all those chunks will be transferred over the wire. So it takes a while for them to be transferred. Now, in theory, TCP allows a packet size up to 64 kilobytes, but unfortunately, most devices on the internet use a much lower packet size in order to provide higher throughput in the number of packets that traverse these devices. So we have speed of light, we have TCP, which is slowing us down a little bit, but there's actually one more thing in TCP that is slowing us down a lot. That's TCP slow start. Whenever you start downloading something, what will happen is the server will respond with just 1 packet. The moment you send an acknowledgement, the server will respond with 2 packets. If you acknowledge that one, it will go to 4 packets and so on. So speed will increase after you've downloaded several of the packets coming from the server. Now, if you combine those 90 milliseconds, because we had to double those 37 milliseconds we had because we have to do the acknowledgements, if you take that into account, and if you take TCP slow start into account, for transferring 256 kilobytes of data, which is not too much, because if you look at a lot of websites out there, you will see some websites have more than a megabyte being downloaded to just load the front page. You will see to transfer 256 kilobytes, That will take you about 10 round trips over TCP to overcome this TCP slow start mechanism. So that means, essentially, our 90 milliseconds will go up to 900 milliseconds because we have to traverse the cable quite a number of times. So even though the distance and even though speed of light is quite fast, TCP slow start and all the devices sitting in between make it actually work slower on the internet. Then there's another issue on the internet, the cost of web load. Serving static files costs CPU and I/O. So for example, when you download a 1 kilobyte PNG file from your server, and it's just the default configuration, what will happen is if you have cookies enabled and you're using cookies, and maybe you're also using Google Analytics and you're sending tracking cookies as well, to fetch that 1 kilobyte PNG image, you may be sending 1 kilobyte of cookie data to the server, receiving 1 kilobyte of PNG image plus 1 kilobyte of the cookie, which is sort of crazy because serving that 1 kilobyte file actually results in a transfer of 3 kilobytes. Which is, again, not too much, but imagine you are using claims-based authentication, for example. Typically what will happen is if you're using a SAML token, it can take quite a lot of space in the requests and responses going back and forth between the client and the server. This does mean that data has to go over the wire. Again, with a 1 kilobyte PNG file, it's really crazy to be sending a couple of kilobytes on authentication cookies and so forth back between the client and the server. On top of that, that's not the only thing, that cookie has to be parsed on the server. So imagine you are using claims-based authentication and you are sending that data to the server. What will happen is IAS will be parsing that cookie, checking if the signature is still valid and so on. So there's a lot of processing going on for making sure that all the cookies in there are in order. But you may not want that. You may just want to be downloading that 1 kilobyte PNG file without having to care about authentication or sessions being loaded or tracking cookies or whatsoever. So there is a cost to serving up static content from your web server. Now, as we can conclude from this, the internet is sort of broken. It's a wonderful thing, but the internet being quite old already, there's a number of issues with it, and one of those issues is browsers and the number of connections they can make. Speed of light and TCP slow start also interfere with our internet connectivity. And then there's the cost of web load in terms of CPU, I/O, and so forth. As my good friend Andy Cross, who's also a speaker at this Azure Conf here, said once on Twitter, the internet sucks and so does your server. It is true. It's bad. There's a lot of things happening there that you probably don't want. And as good developers do, what do you do when you have an issue and when something is broken? No, you do not fix it. You find workarounds. Workarounds for all these things could be if you're using a browser and you can only do 6 connections to one host, simply use multiple hosts. If you go to 2 hosts, you can do 12 concurrent connections from that same browser. So the more host names you are using, the faster the transfer will be because the browser will make more connections to them. Now, of course, don't go overboard there. Don't go for 50 host names to download every resource from a different host name. That's completely crazy. But it does help to put images, for example, on a separate host name, CSS files on a separate host name, and so on. For speed of light and TCP slow start, there's not really a lot of things that we can do about that, except moving content closer to the user. Imagine we have those 90 milliseconds for a TCP packet to travel US East to US West. Well, if we can reduce the distance there and make it 30 milliseconds, remember that 256K file that we were sending east to west? Well, those 900 milliseconds for that entire file will drop down to 300 milliseconds, and we've effectively increased the throughput of our solution there. Then regarding the cost of web load and CPU and I/O going on there, there's a number of things you can do. First of all is serving all that content off a cookie-less domain. So by default, your IAS, your Apache, or whatever will be handling cookies and also and all that. You may want to move all that to a server that doesn't even care about cookies, that doesn't care about authentication, that just loads a file from disk and outputs it on the response stream to the clients. Another thing you can do there is move content off the web server and just completely let someone else handle that content. So for example, if you're using jQuery, for example, on your website, what you can do is make use of the Google CDN. I think Mac CDN also has a mirror. ASP.NET also has a mirror there. So you can just serve the content from those domains and not even care about hosting them on your own server. So one of the ideal workarounds there for all the problems that we had is the Azure CDN. So what's the Azure CDN? The Azure CDN is a service that lets you host content that is stored in a storage account or in a cloud service. And you can put the content in the storage account, put it in the cloud service, and then use the CDN URL, and clients will be downloading from the CDN instead of directly from the server that you are using. It gives you a separate host name where you can even map a custom domain name to the CDN endpoint there. So you can actually make it beautiful and can make it something that's inside of your own domain. But it's a separate host name, which means we have more connections. One host name will be the server serving up the HTML. The other host name will be the CDN host name. So you are effectively increasing the number of concurrent connections that the browser can be making. The Azure CDN also has a lot of locations around the globe where they serve content from, which means we are actually bringing content closer to the user. Because when a user requests a resource from the CDN, what will happen is that the user will actually download the file from the closest CDN nodes geographically and in network topology from where they are downloading this content. And that makes a huge difference because we are moving content closer to the user. And instead of having to download a file from the US when you are somewhere in Australia, you can maybe download it from a CDN node that's within mainland Australia, which is probably much faster than going through all the internet cables around the world. So there's quite a number of locations, as you can see on the map here. The last update of this map was April 1st in 2014. You can find updates on the Microsoft website. I haven't seen any more CDN locations pop up, but I'm pretty sure that depending on where the market wants this to go, other endpoints will be popping up as well. But as you can see, there's a big concentration of CDN endpoints in the US, as well as in Europe, as well as in China and Australia, Asia and Australia there. So whenever you are downloading from the CDN in one of the locations there, you can just download it from the CDN instead of from one of the cloud services or blob storage accounts you have. So how does it work? Imagine I'm a European guy, so a lot of Europeans and especially Belgians go to the south of France on vacation during summer because the weather is nice, and especially if you're from Belgium or the UK or the Netherlands, you will know that weather can be bad in summer, can also be good. But to have a little bit of guarantee of good weather, we go to south of France. Now imagine I'm there, I have my tablet with me, and I'm consuming a service that is hosted on Azure. And that service is hosted in the Dublin data center in Ireland. What happens is, if I'm not using the CDN, every request will have to go to Ireland and go back. And imagine this request takes us 60 milliseconds. Not bad, but also not optimal, perhaps, because if we could download this from a server that's closer to our user here, it would be probably much faster to download this file and get higher throughput from it. So with the CDN, what will happen is, we hit the host name of the CDN endpoint. This will map us to the closest CDN endpoint of our user. And in this case, this could probably be Spain or Paris or wherever this node is located, depending on the network topology again. And our user will make a connection to that node, and that connection will probably take 20 milliseconds, say. Now, if the content is not yet on the CDN node will actually have to fetch the original resource from the original service that you have in Ireland. So that will take time, but because the cable between the CDN node and the data center there is probably a little bit bigger, and the connectivity is much better than you on your dial-up connection in the south of France, this will probably go much, much faster. Now, once that content is downloaded to the CDN node, depending on cache control headers and so on, all the subsequent requests going through that same node will be served from the node directly, without the node having to reach out to the original data center and the data location again. So whenever I do a new request to the CDN node, the content will be served from there instead of from the original data center. And that's obviously much, much faster. So let's create a CDN endpoint through the portal. Now, you may know that Azure has a couple of portals, and CDN is still in the old portal or the old new portal or whatever you want to call it. But I'll create a CDN endpoint in there. So what I can do is just create a new app service CDN, and then quick create. What you will see is that I can choose a subscription in which I want to host this CDN endpoint, and I can also choose which origin I want to be using. So as you can see here, my storage accounts are listed as possible origins, as well as my cloud services. This means that whenever I create my CDN endpoint in the portal, I will be able to either map it to a storage account and then serve content from a storage account, or map it to a cloud service and then serve content of a cloud service. So the CDN will then reach out to that origin in a data center and fetch the content from there. So let's go with a storage account, and let's select this one and click create. Shouldn't take too long to create the CDN endpoint in the portal. However, you may see, if you do this for the first time and you start hosting content on the CDN, it may take an hour or so for all the CDN nodes around the world to know about this configuration and to know where the data should be fetched from. So if you are doing this, please be patient, and during this session I will just use a CDN endpoint that I've created previously, because I don't know when this one will actually resolve from the location that we're recording here. Nevertheless, if I go into my CDN endpoint, you will see that there's a couple of things there. First of all, my CDN endpoints. This is a very strange looking URL, and it's probably not the prettiest URL you want to be serving to your users. But again, using the toolbar here below, you can manage domains and map your own custom domain name to this CDN endpoint. A couple of other options are available as well. We can enable HTTPS and SSL on our CDN endpoint, which is pretty easy. You just click it and enable it. And we can enable query string support, which is also pretty easy to do. Just click the button, and we will see during one of the next demos what this thing does. Now, one remark I want to make here about SSL support and custom domains. As you see, my CDN endpoint here is this URL, provisioned by Microsoft. The SSL certificate used by the CDN is also based on this URL. This means if you want to use your own custom domain name for the CDN endpoint, you will probably see that the SSL certificate is not valid for that custom domain. So I would advise, if you are using or willing to use HTTPS for your CDN endpoint, it's probably better to just use this URL instead of map a custom domain name to it, because of the SSL issues that may potentially arise depending on the browser navigating to the CDN endpoints. All right, so this is my CDN, and just to make sure I'm not confused, I'm going to delete it and work with the nodes I've created previously. So I have one here which is making use of a blob storage account in the back. So this CDN endpoint maps to a blob storage account. How do I get my content on the CDN? Well, it's as easy as uploading the content to the storage account. So what I can do is make use of, for example, the Azure Management Studio, connect to our Azure CDN demo storage account, and then create a new container in there. Now, the container we create has to be public, either on the blob level or the container level. It doesn't really matter for the CDN, but it has to be public. The reason for that is the CDN will be downloading content from the storage account. It doesn't have credentials to download from the storage account, so it will have to be public, because otherwise the CDN will just be caching a 401 unauthorized instead of the actual content you want to serve. So I've created a public container here, demo, and it contains two files, hello.txt and helloworld.gif. And if we look at our hello.txt and copy the blob URL to the browser, we can see this renders a simple hello world. So pretty easy, pretty dull actually. But I just want to show this is just a storage account from which I'm serving the contents. Now, if we copy our CDN URL here and use that one instead of our blob storage account, you will see that we get the same content, and this time it's being served from the CDN. Now, the first time I hit this URL, the content is downloaded from the storage account, but on all refreshes I'm doing right now, the content is actually being served off of the CDN nodes that we have. So that's quite interesting. I actually have another file on there, hello world.gif. So you can serve any type of content, can be images, can be PDFs, can be downloads. So for example, if you're an ISV and you have some software you want to serve up to your users, you can simply put the exe or the MSI package or whatever you want to host on a blob storage account and then serve it over the CDN. No worries there, it all works. Now, as we can see, there's an interesting website called the Azure Speed Test. I've actually been running this one in the background for a bit. And as you can see from the statistics below, actually the location where I'm recording here, North Europe, is the closest location or the fastest one to download files from. So it's not because the CDN is fast and has a lot of nodes. It may well be that a different data center location in Azure is closer to the end user than the CDN. But we can still see the CDN is sort of fighting with the North Europe data center here to sort of make out which one is the fastest to download the content from. So that's interesting. We now have the CDN being the fastest one in here. All right, so let's switch back to our slides. So what did we just do? We uploaded content to a blob container. We made a first request to the CDN endpoint, and the CDN then fetched the content from the blob container. The second request, however, the data was already cached on the CDN node that I hit during my test here, and the content was served from there. So the storage account actually didn't have to do anything for the second request there. So how do you use this in real life? Because obviously I've now been using the clients to upload content to this blob storage container. How would you use this in real life? Well, what you would do is simply create a new blob container, which is public, upload your static files in there, and then make sure your application is using these new URLs. So that's actually a pretty simple thing to do, and you could do it manually, like I did in a previous demo. You could do it during your CI process, and if you are using a blob a storage account as the origin for your CDN, I would actually advise to try and script the upload of the resources you want to have on there in your CI process, so that whenever you do a build on TFS or TeamCity, that the content will actually be uploaded to the storage account there. Another way of doing it is just do it using code, because there's a lot of libraries that you can use. So let's use this CDN in an actual application. Now, actual application may be a bit much to call this thing. I've just created a simple ASP.NET application here, which is quite default. The only thing I changed is the script sources and CSS references that are in there to just download the files instead of use the default minification and bundling. So how do I use the CDN? It's actually pretty simple. The only thing I need is the URL, which I'm copying here. And then I can simply paste it in here, and let's say I want to create a container called demo1 static and serve the content from there. So pretty easy, and we can just basically find and replace in our file here, and content will now be served from the CDN. So let's try this. Let's run the application. And as you will see, this will look very rudimentary, matching my CSS and design skills, to be honest. The CSS and the JavaScript is not being loaded, as you can see. Reason for that is, if we do a view source there, you will see that the content is being downloaded from the CDN, which is crazy because we didn't upload the content to the CDN yet. So let's do that. How are we going to do that? Well, I have a simple action method there, which is called synchronize. And that one will upload the contents to the CDN. And when I go back and refresh, you will see that I now have a nice looking page. All the CSS, all the images, and so on are there. Pretty interesting. And I can just refresh, and my page will still be served from the web server. However, all the static resources that I referenced will be downloaded from the CDN endpoint there. So that's pretty cool to do and pretty easy to do as well. Now, how did I do this in code? I'm using the the storage API there. I'm simply creating a cloud storage account, creating a cloud blob client, and then creating a cloud container or a blob container. So I'm creating a container here called demo1 static, making sure it exists. Obviously, if you're doing this in a CI process and you know that the container is going to be there, you don't have to check every time, but it doesn't really matter in this case because this uploading step is something you don't do on every request, so we can safely add the creative not exists in here. The next thing we're doing there, though, is setting the container permissions to public, to make sure that the CDN can read the content from the blob storage account. Following thing I'm doing is mapping my current application paths, enumerating the content and the scripts paths in there. And then for every file I have, I'm simply creating a new blob reference, setting its content type, more on that in a minute, and then uploading it to my storage accounts. Now, why am I setting the content type here? As you can see, what I'm doing is based on the file extension, which is probably not the best way of doing this, but still, based on the file name extension, I'm setting the MIME type or the content type of the files that I'm putting on storage. Reason for that is, by default, storage will use the application/octet stream as the content type. And in some browsers, and not always, depending on if you're on the internet or the intranet and so on, it may be difficult for the browser to know what it has to do. Because if you download a PNG, for example, if you get the content type image/PNG, the browser will know it's an image and render the image. If we don't do this, you may have cases or situations where the browser gets confused and simply doesn't show an image or doesn't download a script and so on. So the best thing to do is set this content type header in there. Now, as we can see, our files are up there. Now let's make an update to some of the files in there. Imagine it's a Friday and let's find the file there. So imagine it's a Friday and it's always fun on Fridays to sort of play with your colleagues and troll your colleagues. So what I'm going to do here is that in my layout file, I'm downloading Bootstrap as a JavaScript framework. I'm going to edit my Bootstrap file here and put an alert in there. And I want to annoy my colleagues by uploading this one, and whenever they hit the website using the CDN, they will see this test. So let's synchronize again. There we are. And go back and refresh. And our prank failed miserably. Actually, that was intended, because the CDN will cache your content for quite a long time. If you want to pull this type of pranks, there's a couple of things you must do in there. One of the things you can do to expire the content and make sure that the content can be refreshed is in your upload setting the cache control header. So by default, the CDN will cache the content you put on there for quite a while. I think it's up to a week in some cases, so that's quite a while to pull that prank. So if I do this Friday, the prank will work next Friday, which is ridiculous. So what I can do is set a cache control header and set the maximum lifetime of the file that I'm uploading to, for example, an hour in this case. Once I do that, the CDN will respect that timeout and make sure that after 1 hour the content is removed from the CDN node and refetched from the origin, in this case the blob storage account. Now do note that because I uploaded the files previously and I didn't have a cache control header on there, if I now upload the blob using the cache control header I have here, it still will not work. The reason for that is that the cache control header is still the default, which is probably near a week, so the CDN will keep the content for a week. Now, is this on all the CDN nodes? No, it's only on the CDN node that I've just hit. So, for example, if you at home hit the URL of the CDN endpoint I have here, what will happen is you will probably be pranked with this alert in the bootstrap.js file, because the node where you are consuming the file from is a different one from where I'm consuming it from, probably, and you will get different content there. So the cache is not global to the entire Azure CDN, it's local to one CDN node. So keep that in mind as well. All right. So how do we delete content from the CDN? Well, you've just seen you cannot really delete content from the CDN. Even if I would delete the blob from my blob storage container, the files will still be served through the CDN. Why? Well, the CDN has cached them and it will keep them for as long as you told it. And if you don't tell it how long you should keep it, it will be probably near 7 days. So that's quite long. So you have to think about this beforehand. Before you do this, you have to think about this, because you want to be able to update your content, right? So things to do is set your cache control header there. If you put it to a lower value, you will get more updates, but you will also get more requests to the origin. So if you're using, for example, a cloud service as the origin, you will get more requests to that cloud service. Another approach is to use versioning, which is an interesting thing. And the best thing, of course, is to use versioning and setting the cache control header. Now there's a couple of things to consider. I already told you about the different endpoints that the CDN has. Imagine we have a script.js file and we set a max age in the content in the cache control header to 200. And imagine at T200 we download a file from a computer near Paris and the CDN endpoint in Paris responds with this script.js file. Now imagine at T399 we do a second request from somewhere in the UK and we hit a CDN endpoint in London. We would expect that this script.js file would be expired by then, or at least a couple of seconds later, but that's not the case because the cache control header there is still valid, and if we didn't change the file at that moment in time, we will still be serving up the previously cached version from the other CDN node. So do keep in mind that your expiry you set there may, worst case, almost be doubled by all the different CDN nodes that are out there, depending on the usage of all these CDN nodes. So one approach to expire content as well is to use versioning. So what we can do is we can go to the portal and set enable query string support and then add a query string to the URLs that we host on the CDN so that the CDN can keep a different cached version for every file or every version or every query string we put in there. So it's much like the output caching you have in ASP.NET where you can vary by all the parameters. Every single parameter in the query string will bring you a different version of the cached content. So let's see if we can do that first. So if we go back here, what I can do is in my layout file, I've actually created a CDN version variable here, which is just the assembly version that I have in the application. So whenever I recompile and whenever the content of my application actually changed, this value will change as well, and I will be serving up the content that matches the version of my application. So what I can do now is simply append a query string and say version equals and then append the CDN version. Now let's make sure our prank is still in there. There we are. If we now run our application again, you will see that the first time we hit this, we will not be getting a new version, we will be getting a new version. Why? Because query strings are enabled on the CDN endpoint and I've added a version string there. So if I now would recompile my application, upload the file again, I would get a new version and the CDN will create a new copy of the cache. It doesn't really remove the content from the CDN endpoint, but it does help in making sure that whatever we deploy actually works with the version we intended it to work with. All right. Query strings are interesting because there's this concept on blob storage where you can use shared access signatures to provide read or write access to a given blob. Now this can be interesting. If you want to serve up protected content from your storage account using a shared access signature, where you say, for example, between now and the next 5 minutes, the user can download from the CDN, you can simply generate a shared access signature on the storage account and then append that in the query string to the CDN endpoint. CDN will simply forward that to the client, to the blob storage origin, and blob storage will validate the shared access signature and then serve up the content. Big problem there is that if you do not specify the cache control header, your shared access signature will be cached for a week. Which means if you expect the shared access signature to only be valid for like 5 minutes and you do not set the cache control header, what will happen is the CDN endpoint will hit blob storage. Blob storage will calculate the shared access signature and serve you the file because the signature is valid at that moment in time. But if in a couple of days from now, still within that 7-day range there, I request that same URL from the CDN with the same now expired shared access signature, I will still be served the file because the CDN will not do the check on the shared access signature. It will simply forward to blob storage if the content is not available on the CDN node. But since it's already there, because I downloaded it previously, it will simply serve up the file, even though the shared access signature is no longer valid. So if you do want to use shared access signatures on the CDN, be very, very, very wary about the cache control header you put in there, because it really influences what you will be able to do and what you will be able to protect on the storage account. All right, up until now we've been manually uploading files to the CDN, which is sort of tedious. You can script it and add it to your build process, but it may be cumbersome. Depending on your preference, depending on how you want to work, you may not want to do all these steps and upload content to a blob storage account. Maybe you just want to build the application, host the application, and whenever it's running, even though the URLs may be CDN endpoints, you just want it to work. Well, what we can do is create a new CDN endpoint and use a cloud service as a CDN origin. What will happen is that instead of going to a storage account, the CDN will simply go to a cloud service and download the content from there. Small caveat there, it's only the /CDN path on that service that will be hosted over the CDN. And by the way, I don't know if you noticed in the portal, but if you create a virtual machine, infrastructure as a service, you will also see that a cloud service is created in which the VM is hosted. So yes, you can use a virtual machine in infrastructure as a service as a CDN endpoint as well. So you can do the same thing from there. But let's go with cloud services in this case. So let's switch the application. And in this case, let's go to actually the exact same application, just a standard ASP.NET template. But in this case, what I've done is I've kept the bundling support in here. So I'm just rendering a minified and combined version of my CSS and of all the scripts that I have. Now, if I host this one and run this one and actually go to the URL where I have hosted this one, you will see that it still looks pretty ugly. Why? Because the content is not there and the the cloud service and the CDN have no idea on where the content should come from. So what I can do is in my bundle configuration where I create the CSS and JavaScript bundles, I can use alternate URLs for my bundles. So as you can see, to register jQuery, I simply use the defaults there. So I just register a local bundle to my application, but I can also give it a secondary URL, which can be a CDN URL, which is this one. How is the CDN URL built? Well, it's simply the CDN URL that I've created through the Windows Azure portal. With a version number appended because I want to have versioning in there as well. Another thing I have to change is enable the use CDN flag there to make sure that bundling and minification framework is actually making use of the CDN there. If we do a view source on this page, you will see that the bundles are actually requested from the CDN. Now, why are they not being served? Well, the reason for that is, as I told you, the content has to be available on a /CDN URL. And if we copy this one and append /CDN to our URL there, you will see that the file there is not found. So as we can see, the CDN endpoint URL here is not available yet because my cloud service is not serving content over this /CDN path yet. How can I solve this? Well, there's a couple of ways to do that. One way is to change my local bundle URLs to /CDN /bundles and so forth, and expose the bundles on that path using that approach. Now that's one approach, and depending on your preference, you may preference a different approach, and that different approach may be found in URL rewriting. So if we go to our web config and we uncomment this section, you can see that in here I'm rewriting incoming requests to a /CDN /demo2 static URL and rewriting them to the root of my application. So basically what I'm doing is virtualizing this /CDN /demo2 static path and mapping everything back to the root of my application there. Do be wary, do not just copy the thing that I have on screen here, because I'm really rewriting everything. You probably do want to filter to only bundles, for example, instead of everything that you serve through that URL, because otherwise all the data you have and all the files that you are exposing over your cloud service or your virtual machine will also be available on the CDN. Maybe intended, but maybe not intended. So it's good to be wary about that. So let's publish this changed version here. Let's just say publish. I can publish using web deploy. I'm not sure what the password was. It seems to be correct. Let's accept the certificates. And we're live. So if you now refresh the page again, you will see that the page is actually showing and is actually displaying the correct CSS and correct JavaScript files. Reason for that is the URL we created previously is now mapped because of the URL rewrite rule that I had in place there. So you can see if I now go there, that will actually download and try and download the JavaScript file there. All right, a couple of other things. I've told you about setting version query string values. I'm doing that in my bundle configuration here by appending, again, my assembly version, but again, this could also be the date of today. It could be a Chuck Norris quote or whatever you want to use as the version of your content. As long as it makes sense for you, or if it's funny, I'm okay with that as well. Now, we version, but as I told you with serving up from blob storage, also sets the cache control header. So one way of doing that is by adding it to the web config file as well. So what I can do is set my client cache to 1 hour, for example. And this will make sure that the CDN endpoint will only cache the content for 1 hour instead of the default, which is really useful. Now again, this thing is just a sample. This thing works on my entire application, and you probably don't want to do this for all the pages and all the other stuff that you're serving up from your websites. So it may be good to host this in a separate folder which serves the CDN content, for example. So you can say that the location should be CDN and then set this header there. So that's how you do that. One additional thing I wanted to add here is the other stuff I have here. Let's also uncomment that. What I'm doing here is enabling HTTP compression in IIS. What this means is that all the content that I'm serving will be zipped, gzipped, and then streamed to the client. Why am I doing this? Because if you have a large 100 kilobyte CSS file, which is probably not too good, but anyway, if you have that file size, which is basically just plain text, by compressing it, you will probably only get 30 or 40 kilobytes. So the data can be transferred much faster. Remember TCP slow start and our speed of light issue there? By compressing content, we can still reduce the content size and make the download happen faster. So that's one way of doing it. There's a couple of other modules that you can install to do the same thing. But in essence, whatever you hand over to the CDN will be served by the CDN. So if you gzip your output, it will be gzipped by the CDN, and that output will just be cached and then served to the client. So quite easy to do. All right. So in conclusion of all these things, some best practices for hosting content on the CDN, whether you are using blob storage or whether you are using cloud services, is set headers. The cache control header, the content type header as well, preferably. Version your content. And do note that if you enable HTTP compression on the origin, HTTP compression will also be enabled on the CDN as well, which is interesting and works with cloud services as well as blob storage. So if you upload a gzipped version of your content there, the content will be served gzipped from the CDN as well. Now, what if I told you you can also serve dynamic content from the CDN? You can actually do that. Now, let's first define dynamic content, because a lot of people have a different perception on dynamic content. And in the context of the CDN here, dynamic content is content that does change, but not that often. For example, data that's generated using query string parameters. For example, imagine you have a chart that's rendered as an image on your website, and that chart will be the same for the next 5 minutes. Why not serve that chart over the CDN without having the server to actually regenerate this image every request that comes in? It can be, for example, JSON. Imagine you are hosting the World Cup and you want to be able to view the current score and the current number of goals being made for every team in an application you are building. Why not serve up that content, that JSON file, over the CDN with an expiry of, say, 1 minute or 2 minutes? It's still quite short, but it will remove some strain from your web server, because everyone will be hitting the CDN instead of the origin there. So that's dynamic content. So if it really has to change on every request, you probably don't want to do it on the CDN. But for everything that's generated and that can stay on the CDN for, say, a minute, you're probably good with going with the CDN there for dynamic content as well. So let's check an example here. What I've created is a meme generator. If I remember the URL correctly, not on my local host apparently. have to go to this browser, go to my meme generator, and wait for it to load. What I can do is give it some text that will appear on the top and some text that will appear on the bottom. Let's say, when I peel onions, onions cry. You probably know who this is going to be, but let's generate a meme anyway. Here's your meme. We see that instead of generating the image, we've generated a URL there. And if we look at the URL and where it's going, if we look at the properties, you will see that we are serving up a URL, which is on our application website. Now you do see that there's an ID there, which is the ID for the meme we've just generated. So if we copy this URL or navigate to the URL, what will happen is we will hit CDN. CDN will hit our cloud service with the ID. Cloud service will render the meme and then serve it up to the CDN, and then the CDN will serve it up to us. Now, fun thing is, if I navigate to this page again and again and again, the page will be served up from the CDN, and the meme doesn't have to be regenerated every time on the server. So let's have a look. There we go. We have a nice Chuck Norris meme generator. We can do some more things. I can divide by 0. Let's create a couple. There we go. So there's our next meme. Now, how was this implemented? It's actually pretty easy to do. If you look at how we built the previous applications and how we hosted content on the CDN there, it's actually very, very similar. If we go to our meme generator controller, you will see that initially we will hit the index page, and then our index page will post. So this is the form where we enter the text that will be rendered on the meme. Next thing we do is we generate a URL which contains the identifier for the meme we've just added in there. And then when we hit that URL, what we will do is simply redirect to the CDN and then serve the content from there. Now, that serving of the content has to be generated first on our cloud service, and that's this generate method here. So what I'm doing there is simply loading up an image, putting the text on there, and then serving up the image with the correct fonts and font sizes and so on. Now, this action method will only be hit the first time that my CDN URL will be hit. Now, as you may have noticed, if we look at the URL here again of our meme we have, this is not a CDN URL. This is still the application URL. The reason why I chose to do this for this application is that I may want to track the number of downloads of a specific meme or whatever content that I'm hosting on this web application. And by taking this approach, I can do so. So instead of regenerating the content every time, I'm still hitting my server once for every meme that's being downloaded. But what I can do there is track some statistics. Who's downloading this meme? Is the user logged in or not? Maybe show an advertisement or something, and then simply redirect to the CDN to handle the actual work, which is serving up the meme that we just generated in there. So pretty easy to do and opens a lot of possibilities in tracking content. For example, I can give you an example of how we do this in MyGet. We have a similar approach where if you download a NuGet package, you will see that the package is downloaded from our website, while what we do is simply track the download and then redirect to the CDN to download the package from there. All right, so in conclusion of all this, why do you want to use a CDN? Well, because the internet is broken and we need a workaround to overcome the number of connections our browsers can make, the issues with TCP and TCP slow start, and the serving of static content, which is probably not something you want to use the entire IIS or Apache pipeline for. We have the Azure CDN as a good workaround for all these things. Azure CDN can serve up content from blob storage and can do it from cloud services. Do keep in mind cloud services can also be virtual machines, so you can also host your content on a virtual machine and then expose it over the CDN there. We can also serve up dynamic content from the CDN, as we've just seen. If it's semi-dynamic, not changes too often, just generate it once and then let the CDN serve it for all subsequent requests there. And if there's anything you should take away from this talk, it's headers and versioning. Set those headers, make sure you set the cache control header, make sure you expire your content at the correct time or the time you would expect it to be expired, and make sure you version the content so you can actually upload a new version and people can see this new version as well. With that, thank you for watching, and I do hope you enjoy the other sessions of Azure Conf as well.